An electrical panel can be used as a raceway, given certain conditions are met and specific requirements outlined in the National Electrical Code, or NEC, are followed. In the described scenario, where there is a 320 amp service feeding two 200 amp panels located adjacent to each other, and a junction panel is installed on one side of one of the panels, the junction panel is considered a subpanel, and the other two panels are considered main panels. The critical regulation governing this type of installation is Article 300.22 C of the NEC, which addresses wiring in ducts, plenums, and other environmental airspaces. Although this article primarily concerns environmental airspaces, the underlying principle relates to the proper identification and rating of raceways and enclosures. According to Article 300.22 C, raceways and enclosures for conductors must be clearly identified with their maximum allowable voltage, temperature rating, and ampacity. This identification is crucial for ensuring the safety and integrity of the electrical system. Firstly, the junction panel must be properly labeled to indicate its ampacity, voltage, and temperature rating. This information is essential for electricians and inspectors to verify that the panel is suitable for the intended application and that the conductors passing through it are adequately protected. Secondly, the conductors that pass through the panel must be properly sized and protected for the ampacity of the subpanel. This means that the conductors must be capable of carrying the maximum current that the subpanel is designed to handle, and they must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent overheating and potential fire hazards. When using an electrical panel as a raceway, it is important to consider several factors to ensure compliance with the NEC and to maintain a safe and reliable electrical system. One consideration is the physical condition of the panel. The panel must be in good condition, free from any damage or corrosion that could compromise its structural integrity or electrical conductivity. Any openings or unused knockouts in the panel must be properly closed to prevent the entry of dust, moisture, or other contaminants. Another crucial factor is the proper routing and support of the conductors. The conductors must be routed in a neat and workmanlike manner, and they must be adequately supported to prevent them from sagging or rubbing against sharp edges. The conductors should also be protected from physical damage, such as from being pinched or crushed. Additionally, the conductors must be properly insulated to prevent short circuits and ground faults. The insulation must be in good condition, free from any cracks or abrasions. If the insulation is damaged, the conductors must be repaired or replaced. Furthermore, it is essential to ensure that the conductors are properly terminated at both ends. The terminations must be secure and make good electrical contact to prevent overheating and voltage drop. The terminations should also be protected from corrosion and physical damage. In addition to these general requirements, there are also some specific considerations that apply to the use of electrical panels as raceways in certain situations. For example, if the panel is located in a damp or wet location, it must be listed for use in such environments. This typically means that the panel must be constructed of corrosion-resistant materials and have a watertight enclosure. Another specific consideration is the type of conductors that are used. Some types of conductors are not permitted to be installed in raceways, such as certain types of flexible cords. It is important to consult the NEC to determine the appropriate type of conductors for the specific application. It is also essential to consider the rating of conductors when they are installed in raceways. When multiple conductors are installed in a raceway, they generate heat, which can reduce their ampacity. The NEC provides tables that specify the derivative factors that must be applied to conductors based on the number of conductors in the raceway and the ambient temperature. Failing to properly derate conductors can lead to overheating and potential fire hazards. When using an electrical panel as a raceway, it is also important to consider the grounding requirements. The panel must be properly grounded to provide a safe path for fault current to return to the source. This helps to protect people from electric shock and to prevent damage to equipment. The grounding conductor must be sized according to the NEC and must be securely connected to the panel and to the grounding electrode system. It is also important to ensure that all metal parts of the electrical system are bonded together to create a low impedance ground fault path. This helps to minimize the voltage rise on metal parts during a ground fault, which can reduce the risk of electric shock. In addition to the technical requirements, there are also some administrative requirements that must be followed when using an electrical panel as a raceway. For example, it is typically necessary to obtain a permit from the local electrical inspector before starting any electrical work. The inspector will review the plans for the installation to ensure that they comply with the NEC and other applicable codes. The inspector may also conduct inspections during and after the installation to verify that the work is being done properly. It is important to cooperate with the electrical inspector and to address any concerns that they may have. Failure to comply with the electrical codes can result in fines, penalties, and even the shutdown of the electrical system. When planning an electrical installation that involves using an electrical panel as a raceway, it is important to consult with a qualified electrician. A qualified electrician has the knowledge and experience to ensure that the installation is done safely and in compliance with all applicable codes. The electrician can also help to select the appropriate materials and equipment for the job and can provide guidance on the proper routing and termination of conductors. In addition to consulting with an electrician, it is also helpful to review the NEC and other relevant publications. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is important to have a good understanding of the NEC requirements before starting any electrical work. There are also many other publications available that provide guidance on specific electrical topics. These publications can be a valuable resource for electricians and other electrical professionals. In summary, using an electrical panel as a raceway is permissible under the NEC, but it requires careful attention to detail and adherence to specific requirements. The Gintran panel, acting as a subpanel, must be properly labeled with its ampacity, voltage, and temperature rating. The conductors passing through the panel must be appropriately sized and protected. The panel itself must be in good condition and conductors must be routed and supported correctly. Grounding and bonding requirements must be met, and all work should be performed by a qualified electrician in accordance with local codes and the NEC. By following these guidelines, it is possible to safely and effectively use an electrical panel as a raceway. The NEC provides detailed guidelines for ensuring electrical safety, and it is crucial to adhere to these regulations. This includes the correct sizing and protection of conductors, proper grounding techniques, and the use of appropriate materials and equipment. Ignoring these guidelines can lead to serious consequences, including electrical shocks, fires, and equipment damage. Firstly, conductor sizing is critical. The size of the conductor must be sufficient to carry the intended load without overheating. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation type, and installation method. It is important to select the correct conductor size to prevent overheating and potential fire hazards. Secondly, overcurrent protection is essential. Overcurrent devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. These devices must be properly sized and installed to interrupt the flow of current before it can cause damage. The NEC provides guidelines for selecting the appropriate overcurrent protection for different types of circuits and equipment. Thirdly, grounding is necessary for safety. Grounding provides a low impedance path for fault current to return to the source, which helps to protect people from electric shock and to prevent damage to equipment. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal parts. Fourthly, proper wiring methods are crucial. The NEC specifies the acceptable wiring methods for different types of installations. These methods include the use of conduit, cable, and other types of raceways. It is important to select the appropriate wiring method for the specific application and to install the wiring in accordance with the NEC requirements. Fifthly, equipment installation must adhere to standards. Electrical equipment, such as panels, transformers, and motors, must be installed in accordance with the manufacturer's instructions and the NEC requirements. This includes ensuring that the equipment is properly supported, ventilated, and protected from physical damage. Sixthly, regular inspections are recommended. Regular inspections of electrical systems can help to identify potential problems before they become serious. These inspections should be performed by qualified electricians who are familiar with the NEC requirements. Seventhly, labeling is essential for safety and future maintenance. Clearly label all circuits and equipment with their voltage, amperage, and function. This helps prevent accidental contact with live circuits and makes it easier to troubleshoot and maintain the system. The labeling must be durable and easily readable. Eighthly, use approved materials and equipment. Only use electrical materials and equipment that are listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. This ensures that the materials and equipment have been tested and meet safety standards. Ninthly, maintain clearances around electrical equipment. Keep clear spaces around electrical panels and other equipment to allow for safe access and maintenance. The NEC specifies the minimum clearances required for different types of equipment. Tenthly, stay updated with code changes. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay informed about the latest code changes to ensure that electrical installations are in compliance with the current requirements. Regarding the specific scenario, ensure that all the conductors running through the Gentran subpanel are rated for the environment and ampacity. This is especially important as the conductors from the right-hand panel pass through the left-hand panel to reach the Gentran panel. The left-hand panel must be able to accommodate the additional conductors without exceeding its capacity or violating any clearance requirements. Additionally, make sure that the Gentran panel is properly sized for the intended load. The panel's ampacity rating must be sufficient to handle the total current drawn by all of the circuits connected to it. If the panel is undersized, it could overheat and cause a fire. Furthermore, consider the impact of the generator load on the overall service capacity. The 320 amp service must be able to handle the combined load of the two 200 amp panels and the generator. If the combined load exceeds the service capacity, it could overload the service and cause a power outage. In addition to these considerations, it is also important to follow all of the manufacturer's instructions for installing and operating the Gentran panel. The manufacturer's instructions will provide specific information about the panel's limitations and requirements. Failure to follow the manufacturer's instructions could void the warranty and could create a safety hazard. By following these guidelines, it is possible to safely and effectively install a Gentran panel and use an electrical panel as a raceway. However, it is important to remember that electrical work can be dangerous, and it should only be performed by qualified electricians who are familiar with the NEC requirements. It is important to be aware of the potential hazards and to take precautions to protect yourself and others from harm. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you.